Okay, so we're back with Regents Prep 10. We're on question 13. So I was just reading through and I noticed that they're talking about neutralizing, so I'm going to use the titration equation. So I'm going to table T, and I'm going to grab, again, the one we just used before, MAVA equals MBVB, and I'm going to make sure I look. Let's see what I got. I have my volume of my base, I have my molarity of my base, I have my volume of acid, and I know it's HCl, but I want the concentration, so I want that molarity. So I'm going to say, okay, molarity of acid is X. My volume of acid is 24. So times 24 equals 0.150 times 20. So we're going to solve for X. So let's see, I have 0.150 times 20 divided by 24, 0.125 is my answer. So B. Okay, moving on to question 14. We see it says, which compounds are electrolytes? I want to think electrolytes are things, think electricity. And so I want to think of things that make ions. So electrolytes are going to be things like acids, bases, or salts. Remember, salts are things that are ionic. So let's take a look. In A, I like H2SO4, but I don't like this because I see a C with an OH, so I know that's an alcohol. KOH, I see a base. CH4, no, that's just going to be something, well, it's organic, we're starting to learn, and it's just covalent. So that's out. So it's not A, it's not B. KOH would be a base. H2SO4 would be an acid. I like that, and I like that, so I think that's the winner. And I don't like either of those. I have an alcohol, and I have, again, just something organic. So looks like I like choice C for 14. 15, again, another one. What's an electrolyte? I'm, again, looking for an acid, a base, or a salt. So I'm going to kind of scan. Oh, I see an acid. CH3COOH. That is a special organic acid. That Cu ending leads me to an acid, so it's C. 16. When the pH value of a solution is changed from 2 to 1, the concentration of hydronium ions, I want to think hydronium is H3O+. And I'm going to increase my hydronium ions when I do that because I'm going down the pH scale, and as I go down, I get more acidic. So let's think. I'm definitely going to increase my hydronium ions. So we get rid. Now I have B and D by a factor of 2 or a factor of 10. Well, pH, remember that's based on a log scale. Logs are based on pH of 10. So D. 20, given the diagram representing the reaction, I have HCl, I have water, now I have H3O+, and I have Cl-, but it says the water acts as. So I'm going to look and see what happened to the water. Well, I was H2O. Now all of a sudden, I'm H3O. So from here to here, what did I do? I actually have one more H, so I accepted H+, so I want to think, okay, well, I decided accepted, so I get rid of donates, and I want to think, who does that? Well, a base is going to be the one that accepts, so 20 is A. Kind of went out of order. We're going to keep going for a second. 21. What is the color of the indicator thymal blue at a pH of 11? So I'm definitely going to go to my table M here. And if I go to my table M, let's see, I'm on table T right now. Okay, let's think. We were looking for thionyl blue. Thionyl blue is going to be pH 11 would be over here, so I'm going to be the second color. I'm going to be blue. So B. 22. Which compound yields hydrogen ions is the only positive ion? So hydrogen ion is the only positive. I want to think acid, because that hydrogen ion is H+, so I'm looking for acids here. I see a base, I see a salt, nope, nope. I see a base, I see, no, H2CO3, Na, HCO3, H2CO3, H2CO3. I like that both has my H's. So D. See, 17, we're going backwards. When the hydronium ion concentration of a solution is increased by a factor of 10, so my hydronium, H3O+, is going to increase by a factor of 10. That means, how does my pH change? Will it change by 10s? So get rid of that. So does it increase or decrease? Well, I increased my H+. So that means my pH actually decreases because I go down the scale. So oops, backtrack, stop, erase. Totally not. We're not talking about what I think we're talking about. I actually don't like the 10, because if I increase by a factor of 10, I want to think when I move up that pH scale, I go 1, 2, 3, 4, 5, like that. Each change is a 10. So actually, now that I'm thinking about it, I'm actually just going from, if I'm moving by a factor of 10, I'm just going down that scale by 1. So I actually like this one. It decreases by 1 pH unit. 17C. 18. Phenolphthalein is pink in an aqueous solution having a pH of. So phenolphthalein, pink. I'm thinking table M on this one. When is it pink? Oh, when it is above 9. So I'm going to go with B. pH of 12. 3 samples of the same solution are tested, each with a different indicator. All 3 indicators, bromothionyl blue, bromocressyl green, and thionyl blue, appear blue if the pH is. So let's go again to our table M, and let's just check all these out. So my bromothionyl blue is blue 7.6 or up. So I have to be above 7.6. So I'm going to immediately get rid of those two. So I am above 7.6. And then if I like bromocressyl green, that one doesn't help me as much because I know that it's blue when it's above 5.4. So that one doesn't help me as much. And now I can look at thionyl blue. Thionyl blue is blue anytime I'm higher than 9.6. So because of my thionyl blue, I have to be, greater than 9.6. So I like C. We're going back down. Reaction of an Arrhenius acid and an Arrhenius base produces water and a salt. Acid plus base always gives you a salt and water. You should be able to say that in your sleep by now. C. Which acid and base react to form water and sodium sulfate? So I want to think my acid and my base have to have them in it. So the sodium, if I go to table L, let's look for something with sodium in it. Ooh, see that NaOH? That must be my base. So I used NaOH. And then my sulfate, I want to think, okay, sulfate, SO4. Who has SO4? Ooh, H2SO4, sulfuric acid. So I'm going to go ahead and say, okay, H2SO4. And let's look. Sulfuric acid and sodium hydroxide. First choice. It's A. Almost there on the multiple choice. The pH of a solution is 7 when an acid is added to the solution. The hydronium ion concentration is 100 times greater. So I know that's 2 moves. What is the pH? So I started at 7. I added acid. And so I was 100 times. So I'm going 2 moves. I'm actually going to go down the scale. So I'm moving to a pH of 5. See? 10 milliliter sample of NaOH is neutralized by 40 milliliters of 0.5 molar HCl. What is the molarity of NaOH? So I'm going again to table T. I'm going to look up neutralized. I want to think again, titration. So I have VB. MB equals question mark. Here's my molarity of my acid. Here's my volume of acid. So I'll do my work over here. I've got 0.5 times 40 equals X times 10. So I'm going to get 20 equals 10X. So X equals 2. So C, 2 molar. 27, the laboratory process in which the volume of a solution of a known concentration is used to determine the concentration. Let's think. When I use my titration equation, which is MAVA equals MBVB, I think I have the answer. D. 28. Which compounds are classified as Arrhenius acid? So Arrhenius said they need to have H+. So HCl, yes. NaOH, no. NH3, no. It's a base. H2CO3. Acid. Sorry, pause. HBr, we have an acid. H2SO4, I have an acid. I like both of those. HNO3, I like. NaCl, I don't like. So, yep, I like choice C. 28, which 2 compounds are electrolytes? Again, I want an acid, I want a base, or I want salt. I want one of those 3. So I'm looking CH3OH. Nope, I have an alcohol. So I'm already out of there. CH3OH. Nope. KOH, I have a base. CH3COOH, ooh, there's my acid. I have an acid and a base. I like C, and if I'm getting rid of choice D, I like KOH, but I don't like that C5H12. All right, done with the multiple choice. Almost there. So 30, state in terms of the pH scale why the beverage is classified as acidic. Well, it says it had a pH of 3. So I like that. It had a pH of 3. Or you could say it at a low pH. Using table M, identify one indicator that is yellow in a solution that had the same pH value as the beverage. So I'm going to check that pH of 3. I go to my table M and I say, well, who's yellow? Well, I can have bromothymol blue. That would be yellow. And I have, bromocrystal green. That would be yellow. And so would thymol blue. So I can actually put any of those. So let's write them all down. So bromothymol blue, bromocrystal green, or thymol blue. Take your pick. 32. After the beverage bottle was left open for several hours, the hydronium ion concentration in the beverage decreases by 1/1000th of the original solution. Well, if it decreases by 1/1000th, that means I'm going down. I have less H3O plus. And actually that 1000 tells me 3 moves. So if I have less pH plus, I'm actually going to go 3 moves up my scale. So I started at 3, and I'm going to change to 4 to 5 to 6. 6 is my pH. So 33, identify a possible pH value for the rainwater. Let's go back to our reading. It says 2 samples of the same rainwater are tested using 2 indicators in an environmental lab. The first indicator, methyl orange, reveals a distinct yellow color when added to the sample. The second indicator, litmus, turns red when placed in contact. So if I go, I'm going to look and say, well, methyl orange is yellow when it's above 4.4, and litmus is red when it's below 4.5. So I kind of like that 4.4, or you could tell me 4.5, but I like it right in there. Explain in terms of hydronium ions, want to think in terms of hydronium ions and hydroxide ion concentrations, the pH value of the rainwater. So they want me to talk about how much I have of it. So if I'm acidic, then I'm when I have more H plus, then I have OH minus. So my H plus concentration is greater than my OH minus concentration. If rainwater were tested with bromothymol blue, what color would be observed? Well, again, remember that rainwater had that pH of about 4.4 to 4.5, so bromothymol blue would be yellow if tested with that indicator. 36. A student, well, it goes with this. Let's read it. A student titrates 60 milliliters. Ooh, titrates. Table T. 60 milliliters of HNO3 with 0.3 molar NaOH. Phenolphthalein is used as the indicator. After adding 42.2 milliliters of NaOH, the color change remains for 25 seconds, and the student stops the titration. So 36 says, what color change does the phenolphthalein undergo? Well, I just want to look. Phenolphthalein goes from colorless to pink. That's it. 37, what is the molarity of HNO3? Well, I was doing, it's a titrate. So MAVA equals MBVB. I'm getting that from table T. My molarity of my acid, I don't know, but I know I use 60 milliliters. My molarity of my base is 0.3, and I know I use 42.2 milliliters. So I'm going to get my X equals, let's see here. So I've got 60, 0.3 times 42.2, 12.66 divided by 60, I get 0.211 molar. Okay. Ooh, I see 4 flasks here. 4 flasks each contain 100 milliliters of aqueous solution of equal concentrations at 25 degrees Celsius and 1 ATM. Well, before I do anything, I'm going to go through and see what these are. KCl, I have a metal and a non-metal. So I have salt. CH3OH, I have an OH, but I have a C. Here I have an alcohol. BaOH2, I see an OH, so I'm going to think base. CH3COOH, I have an acid because of that Q. So 38 says which contain electrolytes. Again, I can have salts, bases, or acids. So KCl BaOH2, or CH3COOH. 39, which solution has the lowest pH? So when I think low pH, I would be an acid, so CH3COOH. Which solution is a solute that would be classified as a salt? We already identified that KCl was a salt, so KCl. Which solution is most likely to react with an acid to form a salt and water? Well, remember, I have acid plus base gives me salt and water. I need that base then. So my base, BaOH2. Which solution has the lowest freezing point? I'm thinking my crocodile here, where I've got my boiling point increases and my freezing point decreases. And I want more ions. That's what I'm thinking. How am I going to get some ions? So I'm not going to get it from my alcohol. I am going to get it from all of these. Well, who's going to break in the most pieces? BaOH2, because I have two OHs. So I'm going to break up and I'm going to be Ba plus 2. And I'm going to be OH minus, but I'm actually going to be 2 OH minuses. So I actually get both. So lowest freezing point, I'm going to go with BaOH2. Hope I see something about titration. So let's see. A few drops of an indicator are added to a flask containing 35 milliliters of HNO3 of unknown concentration. After 30 milliliters of 0.15 NaOH solution is slowly added to the flask, the indicator changes color, showing the acid is neutralized. 43. The volume of NaOH solution is expressed to what number of significant figures? Ooh, back to significant figures. So let's see. My volume, here's my volume of my base right there. So 30 milliliters. Remember that if I have a decimal's present, I come in from the Pacific side, so I come from the left, I hit a 3 and I keep counting. All 3 of those are significant. So 3. 3 sig figs. Okay, 44. Complete the reaction or the equation for neutralization by writing the formula of each of the products in the spaces. So I have HNO3, which is an acid. I have NaOH, which is a base. So I know that I need to form a salt and water. So my OH and my H are going to join together to be my H2O. So my salt is going to be left over from Na and NO3. I'm going to just double check. Na is plus 1. NO3, I look at table E. It is minus 1. So if you crisscross, you're going to get NaNO3. Acid plus base gives me a salt and water. 45. Show the correct numerical setup for calculating the concentration of HNO3. So I'm using my titration equation again. I have no idea what my molarity of acid is, but I know my volume of acid was 35.0. I know my molarity of my base was 0.15, and I know that my volume of my base was 30. So I'm going to go ahead and plug that in. So I have 0.15 times 30, that's 4.5, divided by 35. I get, say, 0.12857, so I can round that, 0.129. But actually, if I'm doing sig figs, they asked me for sig figs up there, I'd actually write it as 0.13 because I only have 2 significant figures there. But it doesn't matter, you can write that other number. Okay. They're going to make me do another titration equation, I think. So let's go ahead and look at this. 50 milliliters of HCl, I have a volume of an acid. 0.1 more NaOH, I have a molarity of a base. During the titration, the volume of NaOH added to the corresponding pH value of the reaction mixture is measured and recorded in the table below. Okay, so let's see. I say go to the next page. Oops. Okay, so volume of NaOH, they're adding, they get all the way up to 30. pH value, okay. So it says, on the grid on your answer sheet, plot the data from the table, circle, and connect the points. So, okay, we can do this. At 10, it was 1.6. 20, it was 2.2, so maybe here. At 24, let's see how these are going. 2, 4, 6, 8, 2, 4, 6, 8, 10. Yep, they're going by 2, so at 24, 2.9, we're going up a little bit. 24.9, which would be pretty close to that. I'm going up to 3.9. Let's put it like right there. 25.1. All of a sudden I'm 10.1. We'll go right about there. And then at 26, that would be 11.1, right about there. And at 30, I have 11.8, right about there. They want me to circle the points and connect them. That's actually really good titration data. So it says determine the total volume of NaOH added when the reaction mixtures a pH of 7. So pH of 7, let's go up to our scale. 7, I'd be right about, I kind of cut up a little bit. The line would probably be better if I went like that. So pH of 7, I'm probably right about 20. I'd let you say anywhere from 24 to 25. But actually looking at my data, 25 would probably be perfect. Somewhere right around there. 28, write the balanced equation that represents the neutralization reaction. So they added NaOH, and before they had told me, take a peek back, it was HCl. So I had HCl plus NaOH, acid plus base. I need a salt, NaCl, and water, H2O. I'm just going to make sure it's balanced. So my Cl's are balanced, my H's are balanced, my Na, my L, I'm balanced. 49. Another trial, 40 milliliters of HCl is completely neutralized by 0.1 molar NaOH. Calculate the molarity in this trial. So let's see. I have my volume of my acid. I have my molarity on my base. I want my volume of acid, but actually, what's my volume of base? I need it to figure that out. So actually, don't worry about 49. I need more info. Almost there, I promise. 3 more. Using broad student titrated sodium hydroxide solution, unknown concentration with a standard of 0.1 molar HCl. It was recorded in the table, so I have an initial and a final burette reading. So it's determined both the volume of HCl and the volume of NaOH. So I'm just going to do final minus initial. So always just do final minus initial. So for your HCl, 25 minus 15.5, that's 9.50. And for your NaOH, I'm going to have 8.80 minus 5, so I get 3.80. So acid, 9.50, base, 3.80. What is the molarity of the NaOH? Well, they had told me up here that it was 0.1 molar HCl, so I can plug into my titration equation. I'll do it down here. So my molarity of my acid times my volume of acid, molarity of base, volume of base. Molarity of acid was 0.1. Your volume of acid, you get it from your table, was 9.50. Your molarity of base, you don't know, that's your X. And let's see, you use 3.80 milliliters of that. Let's solve for that X. So we've got 0.1 times 9.50, 0.95 divided by 3.80. Oops, I messed it up. .5. Last one. Why is it better to use several trials of titration rather than one trial to determine the concentration of a solution of unknown concentration? Well, really, anytime you're going to use several trials, you're going to get more reliable data. And that's because you can look for outliers. You'd be able to kind of average things, see something way off, get rid of any data that doesn't quite seem right. So basically, we're going to be way more reliable if I do that. Thanks for going through this with me, guys.